Let's look at the molecular geometry for NO2-, the nitrite ion. So we have our Lewis structure, and we're going to look and see how many groups are attached to this central nitrogen here. So we're going to figure out the molecular geometry around the nitrogen. So we have oxygen, that's one, and then we have the other oxygen here. So those are two groups, and then we have this lone pair of electrons. So we have three groups around the central nitrogen, and one of those groups is a lone pair. So we can look at this table here, and we can see we have the three groups, that's our steric number, and we have one lone pair. So with three groups around the central nitrogen, with one of them being a lone pair, we have a bent molecular geometry, and the angle is about 120 degrees. Let's see how we ended up with this bent molecular geometry in a bond angle of 120 degrees for NO2-. So the purple, that represents the central nitrogen. So we'll add one of the oxygens, and then let's add the double bond here. And you can see they're spread out. They have 180 degrees as the bond angle. But we need to add that lone pair of electrons. And when we do that, we end up with this bent molecular geometry. We have 120 degrees. And you can see how that lone pair pushed down those oxygen atoms to give us this molecular geometry. Note that the actual value might be a little bit different than 120 degrees. This is a very general number. So that's the molecular geometry for NO2-, the nitrite ion. This is Dr. B, and thanks for watching.